Today we're looking at measuring segments. And so for the first one, again, just like all of our notes before, we're going to do a kind of a review using some of the vocabulary that we've picked up. And the first thing we have is a point. So it just says draw an example of each. So a point is simply just going to be that individual dot, and we can give it a label. We may call this one point A. The next one is line AB. So remember, that is the line that passes through the points AB, and it extends indefinitely in both directions. And then finally we have ray DF. So it has the endpoint D, and then it extends through the point F and extends indefinitely away from D. So those are just, we looked at those yesterday in our notes about points, lines, and planes. So today we're talking about measuring segments. A segment is going to be the part of the line that consists of two endpoints and then all the points in between. So this segment that they show us over here on the right is HJ. So we have the endpoint H, the endpoint J, and then all the points that we want to label in between are contained on that segment. We name the segments. We've talked about naming conventions. We name segments by their endpoints. This one would be HJ. Here we're going to use the vocabulary. Again, this is the kind of the English lesson, that's easy for me to say, segment of the notes where we have some words that we want to place in or we want to define, whatever the case might be. Here we're just simply filling in some blanks. A ray has one either endpoint, endpoints, line, or points. A ray has one endpoint. A line contains infinitely many points. And then a segment has two endpoints. That's what we looked at earlier there. A segment is part of a blank, and that would be a line. A segment is a part of a line. And then the next three, we just want to place a check mark to determine whether or not the phrase indicates or describes a segment, and then we'll place an X if it does not. The Earth's equator would not be a segment because, one, it's round, and two, it only has, if we picked a point on the equator to start, when we come back around, our starting point and our ending point are exactly the same. So the Earth's equator is not an example of a segment. One, because of the curve. Two, because it would only have one point in space to start and end at. Number 9, the right edge of a book's cover. That could represent a segment. So let's see if I can draw a book here. This right edge represents a segment. Then the third one that we have is one side of a triangle. So any one side of a triangle that we pick would represent a segment. I do that a lot, don't I? Let's see if we can fix it. There we go. The ruler postulate. This is a new postulate. We did postulates 1.1 through 1.4 yesterday. This is postulate 1.5. And postulate 1.5 states that every point on a line can be paired with a real number called the coordinate of the point. So any point we pick on a line, we can give it a coordinate or give it a numeric value, and that would be its location in space. So with problem number 1, it asks what are UV and SV on the number line. Label each point on the number line with its coordinate. We can see just from the numbers that we're given, so we have to make some inferences here. We go from 0 to 2, 2 to 4, 4 to 6. So we're increasing or decreasing by 2. U is between 8 and 12, so it must have the coordinate of 10. S is between -2 and -6, so it must have the coordinate of -4. And then we're just going to fill in the blanks for UV and SV simultaneously down these two columns, and then we're going to justify each statement there in the middle for number 12. UV is going to be equal to 10 minus 14, because we're going from, oh sorry, I forgot to label V. V is 14. So U to V is 10 to 14, so we put in 10 minus 14. And then SV is S to V, which is going to be -4 minus 14. And that is just simply by the definition of distance. And that's why we have the absolute values around these as well. 10 minus 14 is negative 4. Negative 4 minus 14 is negative 28. Negative 28. Negative 18. And when we define what step we took just there, it's simply subtraction. And then the final step is taking the absolute value. The absolute value of negative 4 is 4. The absolute value of negative 18 is 18. And this is just absolute value. And the reason we use absolute value in distance is because there is no such thing as negative distance. Distance is always positive. You could argue, okay, well, what if I'm digging into the ground? I'm creating a hole. But that's still a positive distance into the earth. You can't just have negative distance. Distance is always positive. It's either 0 or positive. The next postulate that we have is postulate 1.6. That's the segment addition postulate. And it simply states that if 3 points A, B, and C are collinear, so remember that term collinear just means they're all on the same line, and B is between A and C, then AB plus BC is equal to AC. So let me just kind of give you a visual for that real quick. We have this line, and we have the point A, the point B, and the point C. So all the criteria met. A, B, and C are collinear. B is between A and C. And the segment addition postulate just states that if we add AB plus BC, it equals AC. So for number 13, we have AB is equal to 5, BC is equal to 4. So AB plus BC is equal to 5 plus 4. That means A to C is 9 units. Number 14, AC is 12, BC is 7. So AC minus BC, 12 minus 7. That means that AB is going to be 5 units. All I do is scroll up and it does that. So maybe I need to go slower. Problem number 2, using the segment addition postulate in the diagram, JL is equal to 120 units. What are the measurements of JK and KL? So currently JK is represented by 4x plus 6. KL is 7x plus 15. Our first line in this justification problem says JK plus KL equals JL. That is from the segment addition postulate. And then in the next line, all we've done is substitute what we're given. JK is 4x plus 6. So we replaced 4x plus 6, or we replaced JK with 4x plus 6. KL is 7x plus 15, so we replaced KL with 7x plus 15. And then at the very outset of the problem, we were given that JL is 120. So we substituted that in. And that's exactly the step that we've taken here, is just substitution. The next step is to simplify everything. So we have 4x plus 7x is 11x. 6 plus 15 is 21. And that is simplify. Or you could put combine like terms. The next step, subtract 21 from each side. That's how we went from 120 to 99. The 21 is gone from the left, so we just subtract 21. And the last step, both sides have been divided by 11. To get our final answer of x is equal to 9. Now we have to go back and answer the main part of the question. It says, what are JK and KL? JK is represented by 4x plus 6. So I'll do JK in purple. So we have JK is equal to 4, and we're replacing x with 9 because that has been computed now. And 4 times 9 is 36. 36 plus 6 is 42. And KL we will do in red. So KL is equal to 7 times 9 plus 15. 7 times 9 is 63. 63 plus 15 is 78. So we have JK is 42, KL is 78. And if we add 42 and 78 together just as a final check, we do see that those add up to be 120, which is the total length of JL. Problem number 3, comparing segment lengths. So in exercises 18 and 19, we're going to circle the expression that completes the equation. AB is from -2 to 3. So that has to be the absolute value of -2 minus 3. DE goes from 10 to 14, so that has to be absolute value of 10 minus 14. Remember, we're using the definition of distance, so it has to include the absolute value. And when we simplify these, -2 minus 3 is -5. The absolute value of -5 is +5. 10 minus 14 is -4. The absolute value of -4 is 4. Question 21 asks if AB and DE are congruent. They are not congruent because they are different lengths. If they were of the same length, then we could make the statement that AB and DE are congruent. The midpoint of a segment is the point that divides any segment into two congruent segments, so it cuts it exactly in half. The left half is equal to the right half. We're going to use this number line to answer questions 22 through 25. For 22, it says point blank is halfway between points B and J. So here's point B, and then here's point J. The distance between those is -4 minus 4, which is going to be equal to 8. So the distance is 8 units between them. Half of 8 is 4, so if we go from -4, 1, 2, 3, 4 units, we get the point, I won't put 0, the point F is halfway between B and J. And we can answer 23. 23, it says the midpoint of AE. So A to E is -5 minus -1. When we simplify that, -5 minus -1 is -4. Absolute value of -4 is 4. That's 4 units. Half of 4 units is 2. So if we move 2 units to the right from A or 2 units to the left from E, both cases will land on point C. 24, it says that point blank, let me answer this phone. All right, we were at number 24. It says the point blank divides EK into two congruent segments. So if we look at E to K, we go from -1 to 5. -1 minus 5 would end up being +6. So we can move 3 units to the right from E or 3 units to the left from K. Either way, both of them take us to point H. For 25, it says find the midpoint of each segment and then write the coordinate of the midpoint. So the segment we're looking at for the first one is AG. A to G is -5 minus 1, that's 6 units. So we're going to move 3 units to the right, and that takes us to point D, and its coordinate is -2. DH is from -2 to 2, that's 4 units. Cut it in half, it's 2. That takes us to point F. And then our last one is A to K. That's all the way across, that's 10 units. Half of 10 is 5, so if we move 5 units in either direction from the endpoints, we land back at point F with coordinate of 0. 26. Find the coordinate of the midpoint of each segment. So we have a segment with endpoints at -4 and 2, so that would be -4 minus 2. That's going to be -6. So half, and then we absolute value of that is going to be positive 6. Half of 6 is 3. So we can move 3 units to the right of negative 4 or 3 units to the left of negative 2. In either case, negative 4 plus 3 is negative 1. 2 minus 3 is also negative 1. For the second part of this, we have negative 2 minus 4. So it's the same endpoints. It's not the same endpoints. I thought they just flipped it on me, but I wasn't paying attention. Negative 2 minus 4 is negative 6. Absolute value negative 6 is 6. Half of that is 3. So 3 units to the right of negative 2, 3 units to the left of 4. In both cases takes us to positive 1. 27. Circle the expression that relates the coordinate of the midpoint to the coordinates of the endpoint. Well, if we look back up at our previous example, if we took negative 2 and added 4 to that, negative 2 plus 4, and then divided it by 2, we would get 2 over 2, which is equal to 1, which corresponds to its midpoint. If we look at the preceding part of that same example, we have negative 4 plus 2 over 2 is negative 2 over 2, which is negative 1. So we are looking at adding the two x coordinates and then just simply dividing by 2. And that's how you find the midpoint given the coordinates. Our next example is using the midpoint. So we're given that u is the midpoint of TV. We want to find out what is TU, UV, and the overall length of TV. First step, TU is equal to UV. That's the definition of the midpoint. We're given that TU is 8x plus 11. They've already substituted that in. UV is 12x minus 1, so we'll write that in ourselves. And that's the substitution rule. The next step is to add 1 to each side. And so we have 12x minus 1 plus 1. And when we simplify, we're going to get 8x plus 12. I don't like this part of the notes because they didn't really give you room for that step. And then 12x. So we're going to subtract 8x from both sides, and that gives us 12 on the left, 4x on the right. Divide both sides by 4, and we get 3. So x has to be equal to 3. We substitute in that value for x into both of our segments. So 8 times 3 is 24. 24 plus 11 is 35. We've just substituted in the 3 for the x. 12 times 3 is 36. 36 minus 1 is 35. So that is u is definitely the midpoint because both segments are the same length. And what we end up with is 35 plus 35 is 70. So the overall length of the entire segment is 35 units, or 70 units. Each segment of that is going to be 35 units. And then our last one, we named 2 segment bisectors of PR. So here is PR, and we're going to underline the correct word or symbol that completes the sentence. A bisector / midpoint may be a point, line, ray, or segment. So that would be a bisector. A midpoint is going to be a line. A bisector could be a point, line, a midpoint will be a point. A bisector could be a point, line, ray, or segment. The midpoint of PR, so we're looking from P to R, and we can see that is going to be the point Q. The line L passes through Q. So the 2 bisectors of PR are the point Q and the line L, and that's all you have to do. So remember, midpoint is a distinct point, and so a midpoint could cut a line in half, but a bisector could be a point, a line, a ray, or a segment. That is the end of this set of notes. Remember to hit me up if you have any questions, and I hope everybody has a wonderful day.